Section 6.6 The log and exponential equations. Objective number 1. We want to solve for the log equations using property of logs and definition. In case number 1, if you have log base a of m equal to log base a of n, you notice that they have the same base on both sides, so we can equal the m and the n. In case number 2, we use the definition to solve for the x. In example number 1, I will use case 1 because I have the problem have log only in the problem. But in example number 2, you have a number in the problem, so we will use case number 2. So case number 1 doesn't have a number in front of the logs. In our problem, we have a number 2 in front of the log. We can move the 2 up, so we can get rid of that 2. Then we will equal both sides. We get the answer is x equal plus minus 3. However, we go back to the log and you remember that the domain of the log is positive. So only 3 is positive. So we take 3 and eliminate the negative 3. Example number 2, we need to have log on one side and number the other side. So we can see that these two logs we can combine using the addition rule. So we will multiply them. X plus 6 times x plus 2 equal to 1. Then you can use the definition 5 to the 1 equal to x plus 6, x plus 2. We can multiply FOIL this, so we get x squared plus ax plus 12 equal to 5 to the 1. Then because of the x squared, I'm thinking about quadratic equation. We will minus 12 both sides, so we get 7. And then we will factor. We get x plus 1 and x plus 7. We will set each of them, and so we will get these two numbers. Now we find the domain of each log. The first one we have x plus 6 greater than 0, and the second one we have x plus 2 greater than 0. That means the first one take x greater than negative 6. The second one take x greater than negative 2. We draw the number line. Negative 6 is smaller, negative 2 is bigger. So negative 2 is bigger and negative 6 bigger. Both of them on the right side of negative 2 and negative 6. To find the interval that satisfies for both conditions, we will look at the common one, the interval that satisfies for both. So the interval is x greater than negative 2. In our answer, negative 7 is outside. Negative 7 is right here, is outside the interval. So we only take x equal negative 1. In example number 3, we have everything is log base e. We are thinking about case number 1. So in case number 1, we will have log on both sides. We can combine this. So ln of x equal ln of x plus 6 divide x plus 4. The minus become the division. Now you can equal the m and the n. We have a fraction in the equation. We need to get rid of this fraction. We will multiply both sides by x plus 4. Then we will get x squared plus 4x and cancel out the x plus 4. Then we will thinking about quadratic equation. We will minus the x and minus the 6 both sides. So x squared plus 3x minus Oh, sorry, the problem is x minus 4, not plus 4. So we have everything is minus 4. So we got x minus 4. So we will have negative 5x instead of positive 3x. Minus 6 equal to 0. Then we factor this. We will choose the two number is 6 and 1. And the 6 will be minus and the 1 will be plus. So x equal to 6 and x equal to negative 1. We find the domain for 3 log. The first one is x greater than 0. The second one is x greater than negative 6. And the third one is x greater than 4. Which interval satisfies for all of them? Greater than negative 6, greater than 0, and greater than 4. All of them on the right side of all these numbers. So the interval, common interval, that is the interval that contains the 3 color that I highlight. So that is have to be greater than 4. So the interval is from 4 to infinity. Only 6 works. So the answer is just 6 in this problem.